Wind is an inexhaustible source of energy. Natural energy for a secure future. In order to gain higher energy yield, we increasingly need high-performance plants and optimal wind conditions. These conditions are already there, out at sea. This is where we are able to construct plants with the necessary dimensions and harness the consistent force of powerful sea breezes. The future of wind energy lies offshore. WeserWind GmbH Offshore Construction GmbH is part of the future of wind power. In its development of new offshore foundation structures, we can draw on the long-standing experience of our parent company, WeserWind Holding GmbH. WeserWind GmbH Offshore Construction GmbH was established in 2002. By working closely with project developers, research institutes, auditors, and insurance companies, and by deploying our production engineering know-how, we can offer cost-effective foundation structures for offshore wind farms. Our company's location in the North German city of Bremerhaven offers ideal conditions for these ventures. The coast and one of the world's largest deep-sea ports is close by, and our facilities are situated right at the docks with easy access to motorways and railways, offering the perfect infrastructure for convenient series production and logistics. One of the major technical challenges in constructing offshore wind farms is the foundation structure, especially in Germany, where most of the offshore wind farms are designed for water depths exceeding 20 meters. We need innovative and above all affordable foundation structures. WeserWind GmbH Offshore Construction GmbH offers several basic types of foundation structures for offshore wind farms. For example, the monopile, the tripod, and the vario-base jacket. In order to reduce the costs of the foundation structure, our approach is integral. We closely examine the design of the planned structure as well as all related production steps, including the offshore installation process. Only this procedure ensures we can assess, control, and finally reduce the costs of the foundation structure. Offshore Foundation Monopile. The project met mast Amrumbank West. In April 2005, the Metmast Amrumbank West was installed 35 kilometers southwest of the island of Amrum, between the offshore wind parks Amrumbank West and Nordsee Ost. Since then, the Metmast is providing important data for the operation of both wind parks. The Metmast was erected on a so-called monopile, a massive steel pipe firmly fixed in the ground, 23 meters deep. This monopile carries the measuring cabin, the center controlling the more than 30 devices attached to the tower above and below sea level. On top of the cabin, the steel latticed mast towers 90 meters high above the water. The entire construction measures around 130 meters in height. In the production facility in Entrebroek, the 63-meter-long monopile has been fabricated. It is made in 3 sections and has a total weight of about 290 t. The raw material is especially tempted for offshore steel up to 78 millimeters thick. Only top quality steel will do. The material is shaped in a computer-controlled bending press. Then the tubes are subject to longitudinal seam welding and a number of production steps inside and out. Every finished component then is subject to visual, ultrasonic, and magnetic inspections. Both ends are sealed with waterproof caps because the monopile will have to float to its offshore destination. A major challenge for engineers and technicians alike is the construction and fabrication of the 60-meter tall lattice tower. Because of its proportions, the IAG, an affiliated company of WeserWind GmbH, has produced the tower at the site of Mülheim an der Ruhr in several parts. These component parts are then transported by barge to Bremerhaven, and there they are assembled into two sections. On the extension arms, which are up to 7.5 meters long, technicians install metering devices at 8 different levels. The jack-up barge MEB JB1 is waiting in the harbor. Its rotary crane can handle load up to 270 T. The pre-assembled measuring cabin, both segments of the lattice mast, and the hydraulic hammer are carefully loaded and firmly secured to the deck for transport to the location. The monopile is ready and waiting in the harbor basin with its end sealed by custom-made caps. The heavy towing gear has already been fitted. The weather forecast has promised a calm sea for the next few days. The project management gives the go-ahead for the offshore installation of the Amrumbank West Met mast. The monopile is towed by 2 additional tugboats. They set off, taking course for Amrumbank. At the offshore construction site, the sea is still calm, but covered in dense fog. In the evening, the fog starts to lift, so the tugboats are able to maneuver the monopile into the right position for the crane. Finally, the monopile is vertically suspended into the piling frame, held in position by the crane, and its own controlled buoyancy. Weather conditions are still rough. Divers detach the clamping bolts on the massive bottom cap. Trough 2 connections in the upper cap of the monopile, compressed air and water can be introduced. Slowly, the pressure inside the monopile is increased until the cap becomes detached due to its own weight. The piling supervisor carefully checks the position of the monopile because it has to be perfectly vertical. Later corrections in the pile driving operation are not possible. Through further reduction of buoyancy, the lower end sinks into the sand. Now it is time for the hydraulic hammer come into action. A 30T piston, hydraulically accelerated inside the hammer, drives the monopile 23 meters deep into the sandy seabed. Now the measuring cabin, with a pre-mounted adapter, is placed onto the flange of the monopile and firmly bolted together. The first segment of the steel lattice mast also finds its position and will be carefully secured. With the top part of the mast being installed, the entire construction reaches its final height of 90.94 meters above mean sea level. The project was successful. The Met mast is standing at position 35 degrees 30 minutes of northern latitude and 7 degrees 43 minutes eastern longitude at Amrumbank West. Now the experts eagerly await the data the Met mast is going to supply. Offshore Foundation Tripod, the Project Multibrid M5000. In Bremerhaven, the world's first offshore wind energy turbine with an offshore tripod foundation constructed by WeserWind GmbH Offshore Construction Gerksmarine had been installed. The Multibrid M5000, with its energy yield of 5 megawatt, has been operational since December 22, 2006, and is currently being tested on land. The multi-megawatt plant is used offshore, where the water is between 25 and 35 meters deep. These depths require resolved structures in order to obtain high stability. Therefore, the WeserWind GmbH offshore construction Gerksmarine has developed the tripod foundation structure. Before series production could begin, the assembly of a prototype helped to gain important experiences in assembly and manufacturing processes. This results in minimized material usage and a long service life. And this is what the enhanced steel construction looks like. Including the first tower section, the tripod is approximately 47 meters high and 600 tons in weight and was developed for an operational depth of 30 meters. For operations offshore, an even heavier weight is planned in order to withstand the pressure of the waves. At IAIG's parent plant, the pile guides for the steel construction are produced. These alone, with a height of 9 meters, are about as high as a family house and have a diameter of almost 3 meters. Each pile guide weighs about 35 t. By using an automated computer-controlled flame cutting technique, the top and lower bracing profiles are cut to size. These then form the connections to the pile guides and the center column. Here the challenge lies in working the welding seam precisely so that its angle stays constant the whole way. The smallest differences in the end measurements of each component are detected, and a so-called best fit analysis is applied. This is done to determine the best joining partners for each specified assembly position. In addition, by using new computer-controlled production systems, one can determine production times. The construction management tool allows a simple and clear scheme of the logistics. This software makes sure that the individual matching components, which result from the best fit analysis, arrive at the corresponding site. Thus, more than 800 tons of steel arrive according to plan at the specified site. First of all, the pile guides are positioned and then aligned exactly on top of the prepared foundation on 3 plates. Afterwards, the center column, the upper and lower sections are erected. Erecting the construction is precision work. Therefore, all parts are once again measured, and the results compared to those from the first best fit analysis. Only after a renewed check of the best fit results, the items are released for assembly. The bracings, which are produced using the most modern computer technology, are lifted to their specific assembly positions. This maneuver means precise work for the crane driver. Because welding the complex profiles is very costly and challenging, the workers revert to proven automatic technology. The aim is to automate the assembly and welding operations as far as possible. In this way, the production period and costs are minimized and the quality of the weld seams optimized. An automatic submerged arc welding machine is used on the center column. Because the submerged arc welding is done horizontally, special technical procedures are required. After welding has been completed and all the weld seams have been checked, corrosion protection can be applied. For this, the complete tripod construction is covered up. Once the coating has been applied, the assembly of the remaining tower sections can begin. One of the biggest mobile cranes in the world is required for this assembly. This crane can lift up to 1,500 tons. Since the beginning of December 2006, the multi-brid M5000 turbine and its rotor spider have been mounted on the first prototype tripod. The unit is ready to go. In the company of top politicians and business leaders, the wind turbine is officially put into operation. Offshore foundation Vario-based jacket, the Project RE Power 5 megawatt. Since February 2008, this prototype of the Vario-based jacket stands near Bremerhaven, erected by WeserWind GmbH Offshore Construction GmbH on behalf of RE Power Systems AG. 340 tons of steel have been used to form a 57 meters tall structure, which spans over an area of about 17 by 17 meters. In the future, this modular construction made of standard elements is going to carry wind power stations at sea and cope with enormous demands under extreme weather conditions. The foundation structures, called the jackets, are a construction of standard tubes which are welded together with so-called cast iron knots. As custom-made pieces, they are already used in the offshore gas and oil industry to work for foundations in larger depths of water. A serial use in the offshore wind industry enables wind park sites in waters of over 20 meters in depth. In cooperation with the plant manufacturer Repower Systems AG Osnabrück, the experts of WeserWind GmbH Offshore Construction GmbH, using computer-based scientific algorithms, developed the basic design of the structure, which is capable of meeting the enormous requirements at sea. Computer-aided, the construction also is optimized regarding the material used. The Friedrich Wilhelms Hirte Stahlgust GmbH is one of the few foundries in Europe which processes the technology to produce thin wall components with sufficient static strength. Here they use processes which help to optimize the features of the steel in a way that cast and steel elements can be well welded together. To ensure this, the steel used is equipped with a low-carbon equivalent.